Okay, as you realize, well, if you don't know, my name is Alexandre Banks. I am sitting in my room right now, recording this at my desktop with my computer. It's not a laptop. So, I'm trying to sound all fancy and stuff like that because I'm about to explain some really deep stuff. Now, this deep stuff is, you notice I just turned the volume up. Some theories of the universe. And, well, first of all, let's just start with the theory of a universe. So a universe is basically, well, you've got atoms, and then you've got molecules, and then you've got cells, and then you've got life with cells, and then you've got, organisms. And then you've got the planet, which those organisms are on, and then the solar system, and then, of course, our galactic neighborhood, and then the galaxy of the galactic neighborhood, and then cluster, open, or globular. I think ours is I think it's a globular cluster, in which the Milky Way is in. And then, of course, there's superclusters and supercluster complexes. And that's basically all we know. And we're probably just going to keep discovering bigger and bigger as we have before. But the thing about that is that I have a couple of rules for universes. And the first one is there's an infinite number of universes. Now, if there was an infinite number of universes, then there would be an infinite number of space. Now, you just think about it like maybe a couple of circles. Anyway, the circles are just like random little circles, and they're all next to each other. They're all taking up different amounts of space, and they're all there, but they're all next to each other. You never think about if the circles are, what if they're spheres? Because then they have to be more than that dimension. And think about it. Scientists have theories that there are 11 dimensions. So if there were 11, then they'd have to be more than just 4-dimensional, or 3, I guess. So you've established that part, I guess. But the thing about that is, my second rule kind of interferes with that. Each universe and its individual is infinite. Now, there's an infinite number of universes. Remember, like you said, a bunch of circles, spheres, tesseracting circles or whatever. But then, if you have every universe that's infinite, there's no shape to it, really. So, yeah. Anyway, well, if you notice any weird noise, that's just because I'm pausing to do random certain things and I'm stitching this together slowly. So, you think about that. But if, like I was saying, every universe is infinite, it has no shape. It can be whichever shape, but that shape is infinite. So it can't even fit on a space as big as, well, anything just right below the number below infinity, which doesn't exist. So, then you've got a bunch of other rules with that. But, if you think about it, then how do you get from one universe to another? One person's theory is you don't. And, well, that may as well be very, very possible. But the thing I say is that, if you travel at the speed of light, and if you're talking about tesseracting, then you're talking to Madeleine L'Engle about this. But science does actually prove that a tesseract is the 4th dimension. So, that's just people's theories. But, yeah. If you have that, then all you need to do is just travel at the speed of light, and you reach another universe. But the speed of light, the thing about that is the speed of light is a limited number. It's like 32,008,000 something. But the thing about that is nowhere near infinity. Actually, if infinity is 1, then that is 0. Because if infinity is 1, then every number is 0. And that is 1 of every number. So, to resume that, you basically can. But then another thing is, what if you can't? well, what would other universes look like? Would there be life in them? I'm assuming so. But then, basically, I mean, if you think about it, there's a thing which people have come up with, which is called quantum foam. And people are assuming that quantum foam is the material of which the fabric of the edge of the universe is made out of. Now, as I've mentioned earlier, I do not believe that there is really an edge to the universe. Instead, it's probably just that the universe goes on and on and on and on. Now, another thing is, think about this. What if people could just jump to one universe and another? Well, I mean, think about it this way. If you're driving and you're going along a path and you go 60 miles per hour for 12 minutes, you're going to reach a place. But then if you go 80 miles per hour for 24 minutes, you are going to reach, you start out in the same place, you're going to reach a different place, which is farther than the place you reached before. Now remember the thing I was saying about universes being infinite and there being an infinite number of universes. And there being an infinite number of universes means that if you teleport from one, then you can literally go to any universe. Because remember, they're not just all circles or spheres. They're like in the same space. And they're infinite. So you can hop from one to another without moving in space or time at all. But the thing is, which universe does everything just decide on? Which universe does, like, the quantum speed that you're going at decide on? Now, the answer to that is that, well, really, I haven't thought up this yet much, but a little rusty answer to that is, think about this. Just group up universes into a little group, right? Because planets come in groups, and those are solar systems. Solar systems come in groups, and those are galactic neighborhoods. Galactic neighborhoods come in groups, and those are galaxies. Galaxies come in groups, and those are clusters. Clusters come in groups, and those are superclusters. Superclusters come in... Okay, you're probably going to get what I'm saying by now, but think about just putting universes in groups. Now, one theory that I have is that if you teleport or just transport to one universe from your original universe, there is a 0.0 with a bar on top of it, which means infinite zeros, 1% chance that you're going to go to the universe that you came back in. And remember the bar on top of the zero, that means that it's an infinite number of zeros and there's an infinite number of universes, so that only makes sense. So there's basically very, very little chance that you're going to go back home. But suppose you get split. Suppose you get, carried in between the two universes, and you have the same body in space, but different parts of your body, suggest your liver's in this universe, and your head's in this universe. Well, your whole rib cage is in this universe, and your legs and feet are in this one, when just the tips of your fingers are in this one. That would be a little unusual, of course, but you're still in the same space and time. Well, I'd like to think about it this way. All universes take up the exact same space and time, but space occurs differently. So each universe is infinite. But, things are the same shape. And of course, things will be in the same place, but they might be altered and in a slightly different place. And there's an altered time path for everyone. So if something really, really terrible happened to you, like your refrigerator, oven, and grill, and your desk, and computer, and bed all went out the window. Suppose you just go to another universe and bam, you've got them all back. But then you have to deal with the idea of there being another you. Anyway, well, suppose there's this. Ones that are very, very close in time passages and very, very close in relative space, then you can group them into different groups. So let's review a little. Okay, the theories that I have for universes is, remember, ones that I came up with a while ago are, there's an infinite number of universes, which is 1. Every universe in itself is infinite, which is 2. And each universe occupies the same space, which is 3. Ones that I more recently came up with is that whenever you try and travel in between one universe and another, what will happen is you probably won't go directly, but get splinched in between either half of infinity or just all of the universes, which means that even the neutrinos in your body can't get splinched, so you'll just get turned into a bunch of photons in the original universe in which you came from, and the new you will be recreated in the other universe, so you will have 1,000,000 minus 1 clones, and then you will also the original you will just be a bunch of photons. So if that didn't happen, a backup theory I have is that different bigger parts of your body, like I said, your liver, your fingertips, or your head, will stay in like different universes, while the whole rest of your body and your skeletal ribcage and feet will stay in another one, although those are just parts. So maybe your head with like an exact atomic fraction of your neck. Now, here's another theory that just came up recently. The only possible way to categorize universes, and this is also part of why traveling at the speed of light will take you to another universe and you might get splinched. Well, the reason why is, like I was saying before, put universes into little groups. Now, how you do this is you go down to photon level, and actually, photons are bigger, slightly bigger than neutrinos, and if you think about this, if you're not really smart enough to know what a neutrino is, you have an atom. Inside the atom, you have an electron. Inside the electron, you have quark. Inside the quark, you have a neutrino. And you have, actually, neutrinos pass through everything. They're just these whizzing particles that kind of make up matter. And then, if you have neutrinos, photons, some people think light comes in waves. Some people think a particle. But I know this is a little weird, but I think that light comes in a wave made out of particles, which are photons. They're slightly bigger than neutrinos. So think about this. If you take this universe, which is infinite, therefore has an infinite number of planets, and has an infinite number of suns, has an infinite number of things with atoms on them, molecules, therefore has an infinite number of atoms, therefore has an infinite number of electrons, infinite number of quarks, and therefore the universe will have an infinite number of neutrinos. Now, if we just group the neutrinos on our home planet, we will only be grouping like 0 of them in the universe, if you're talking metaphorically, because if the universe is infinite, and there is an infinite number of universes, then all you have to do to get outside yours is use yours as an example. And think about this. The universe in itself is probably occupying, if you go faster than the speed of light, you're probably going to go through so many universes at once that you hit an edge. And if there is that edge, supposedly made out of quantum foam, then that'll be it. So think about all the neutrinos on the planet. Remember, if I said infinity is 1, then every number even below infinity, just below infinity, is always 0. So if you think about it, if you think about the universe is all the universes, and the planet is just a part of that, and then you try and find all the atoms on the planet, then, or neutrinos in my case, then it will count up to be 0. So think about this. The only way somebody can reach infinity by only going halfway to infinity, which is basically still infinity, but sometimes it may be less, is doing it logarithmically. Now, logarithmics, if you are an 8-year-old watching this and you don't necessarily know what logarithm is, well, logarithm is when you count from one number. Counting linearly is 1, 2, 3, 4, 5, 6, 7, all the numbers on the line. But counting logarithmically is that number times the distance each time. So if you go 1 and then 2, you start off linearly, going 1 and 2, and then 2 times 2 is 4, 4 times 4 is 16, 16 times 16 is like, what, 128? I think 256 times 256. I haven't figured that out yet, but oftentimes people mistake it for doubling the number, which is a square. Well, logarithm is a little more intense than squaring, or maybe even cubing, or anything. Logarithm is, well, think about this. If there is an edge to the universe, then if we measure all the atoms on the planet and say, hey, that's an average for this size sphere around the galaxy, which is probably this size sphere around the cluster, and that's almost there because it's an open cluster, which is probably this size sphere around the supercluster, this size sphere around the supercluster complex, which I am going to say is also a globular cluster. And don't blame me for thinking that everything is a globular cluster, but that's just, I'm going to say, because a lot of things are spheres in the universe. So the thing about that is, if supercluster complexes are the biggest thing, then all you need to do is just take a, ratio of atoms per molecule and just take an average, a median, and give that to the world times figuring out how many atoms are in the world, give that to the solar system, figuring out, and by the solar system I mean as big as the Oort cloud, like even the belt outside, and by that I mean figure out how many Earth-sized planets could fit inside the Oort cloud, which is probably be like 600 million? I don't know. Well, think about it, they're all packed together. And then think about how many Oort clouds can fit inside our galactic arm. How many of those, you probably already know, can fit inside a galaxy. How many of those can fit inside a cluster. How many of those. And think about this. I mean, a planet, let's say solar system is 10 times as big as a planet. That's a really weird comparison, but solar system's 10 times as big as a planet. And then, planets are 10 times as big as, like, let's say continents. Continents are 10 times as big as countries. Countries are 10 times as big as, but kind of the reverse scale. So it's going logarithmically if you do that in reverse. Now that's always going up in scale. Now, okay, let's review. What I'm going to say is I have just come up with a really, really weird theory just yesterday, which is, in fact, that, we're about to reach the 2-minute mark. It's, in fact, that if you think about it, if you just group universes let's say here's one universe, and then there's another universe, and let's put those two together. And if it's logarithmic, then it will reach the smallest number below infinity, which is 1. That's to 0. But think about just putting them in groups of anything. The possible number of universes can be anything times 2. Now, why I'm saying this is very, very unusual sounding, but think about this. If you have one universe and group it with another, and group it with however many, and maybe just do that squared, then the number of universes will be the smallest under infinity, because the planet's finite, finite, the solar system's finite, I don't know. So is the galaxy, so is the cluster, so is basically everything we know, and the universe must. Now, some people think the universe is flat. That's technically impossible because, if the universe was flat, then we wouldn't be able to exist on a three-dimensional plane. Only just two, which is, I think, X and Z, which is coming straight forward. Although, then you couldn't really look at it from any other angle. Some people think the universe is a saddle. Now that may be very, very well as true, and actually a bell shape. Because think about this, everything in universal physics is based upon logarithmics. And if you think about this, like I was saying, you put universe in a group of 2, and the number of universes is always smaller under infinity, so it could technically be anything, but in logarithmics, it always clings to the nearest number, whereas in linearism, or whatever, it can go to any number, it just goes around. And then think about that. The smallest number in a group is that times that number. Now, if you think about it, squaring, which is very similar to logarithmics actually, is if you have like 4 times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, and you have that, and that's basically that. It's probably always going to be a square. Now, the interesting thing about that is the smallest number group you can put together, besides 1, which doesn't make it a group, is 2. And the smallest logarithmic you can put together is times 2 times 1, which now squaring is always a number of things, so cubing is times 2 times 2 times 1 if you're cubing times 2. Now, if you're just cubing the number 2, but if you have that, then most potentially, normal number of universes in this theory would be 4. Now, suppose you're talking about my infinite universes theory. That's a little hard to imagine, and that may as well be true. On my scale, there's a 50% chance that that's true, but think about this. There is actually slightly a 49% chance on that and a 51% chance on this, which means if you try 100 times, you'll get this once more on like betting or something. And if you think about this, the main thing in this is there's only 4. Now, that's a little hard to imagine, but, 4, as I was saying earlier, altered time paths, 4 different space paths, I guess, and 4 different space-times. Now, 4 is such just a little number you slam on the ground, and you can do a lot of stuff with it in normal, like algebra, pre-algebra, and, even geography. I forgot it. Anyway, well, you can do a lot of stuff with it, and if you think about it, in normal probability, it's just a little number you slam on the ground, or just a little stick you throw at the wall, and it isn't much. But if the highest number of universes can be infinite, and it has to be below infinity, since everything is finite, then it will always be the smallest number below infinity, because like I was saying, there's no number that's directly below infinity, because infinity isn't a number. It's just infinite numbers going on and on and on. So if you have infinity minus 1, well, there isn't an end, so there isn't a way to find the end. So the highest number it will assume is always the number above 1, which is 2. So if you're always thinking infinity and it has to be smaller, then it won't just think something right off the bat like 113 or whatever, like 1264. But then think about that. The most probable number that is below infinity is, all of them are very probable, but the most probable one for humans thinking about it is 2, the number right above 1. But if you put them in groups, and like I was saying earlier, the number of universes you have is always below infinity, and it's finite, and then you have that, well, it's probably going to be 2 also. And 2 squared is 4, so there you have it. My newest theory is that there are 4 universes, but then what would these look like anyway? Now, P.S., this might just be a little long P.S., but as I was talking about before, what happened was how some people thought it was a saddle shape. I'm probably going to think it's a sphere because it's infinitely symmetrical. Then, well, basically, we're going to have saddle shapes are very, very logarithmic. In fact, they're double logarithmic. Because, put it this way, it's a little hard to show, but if you have something that's going diagonal, but much more x than y, much more horizontal than vertical, and then you attach it to one that's a little more, and it's just as much x as y, and then you attach it to one that's very vertical, and they're all attached in like a right line, going the right, not like good, but going in the right direction. And if you think about that, then you attach it to a bunch more that are growing more and more steadily. They're growing more and more steadily vertical, but it's extremely hard to notice. So you've got like 1, 10, 15, 17.5, like 18.55, 19.555, 19.75, 555, and you're just going to keep going to reach 20, but it's always half as much. But then to reach 20, you get a little more. Finally, you reach 20, and then 30, and then 35, and then 37.5, and then 38.555, and then, you get more and more and more down. And if you keep doing this, the numbers get closer together, and finally they get farther across, closer together, farther across, closer together. This is called what you call a dope sign. Normal sign is just 1 to 6, 6 to 12, 12 to 19, 19 to 12 to actually 16, I think. 16 to 23, 16 to 20, 22, and the numbers get smaller, but there's much more horizontal than vertical, and it's more normal shape. The dope sign is like, you can fit in half of a normal, and half of just a dope sign, you can fit a circle in kind of the dopey part of the dope sign, which I don't know why they call it that, but yeah. Now picture this. Since everything in the universe, as I was saying before, the 4 universes are based on logarithm, then that may as well be very, very true. But according to scientists, there are 11 dimensions, and which we only experience 4, or maybe 3, I think 3 of. Yeah. Although if you count dimension 0, that's just 1 point. It's just there, and it's as big as a neutrino, and maybe even smaller. Maybe like a zoton, which I just call theoretical particle. Now, that's pretty interesting, because we only live in 3 dimensions. Now, lizards only live in 2. And I'm pretty sure there's some kind of weird, like, bacteria animal thing that has very bad vision, and it only lives in 1 dimension. But I'm pretty sure, maybe, we don't know this, but maybe birds live in and they experience 4 dimensions. Now, since there are 11, I've kind of come up with a list. 1 is the dimension which is just a line, keeps going on. 2, it's a square. 3, it's a cube. 4, 2 planes can exist in the same. Well, 4 is basically you can hop from one space to another. And let's say you're in one of the 4 universes and you hop to another. Now, that's just without even moving in space or time. You basically teleport there. And then 5 is that 2 planes can interexist and interconnect on the same space. 6 is that 2 planes can twist in opposite directions while staying in the same place and being the same plane. So you can exist on 2 different planes and experience both things at once, which I know is a really, really weird thing, but it's like you split into 2 views. 7 is the manifold dimension, where it's basically a little perfect middle dimension, where you can not only hop, but you can also hop in between planes, and you can hop in between planes while existing in between 2 planes, which is like kind of a middle. Number 8, which is the timetable dimension, where time, you can control time by moving in space. And number 9 is the Fox, I think, something like Fox dimension, where sometimes things are improbable, and it's a very unusual dimension. I forgot what it's all about. 10th dimension is, the 9th dimension is the improbability dimension. The 10th dimension is basically the infinite dimension and the 11th dimension, which people think is the highest. If you're in string theory, then there are 11 dimensions. If you're in superstring theory, which I don't really know what is, then you are in 10. Now, if it's just normal string theory, the 11th dimension, in my case, is dimension paradise, where is basically a direct copy of the infinite dimension, but there's just a slight difference, and there's only 0 with a bar on top of it, like I was saying before. Infinite, 1 difference in between the two. So you can basically exist in 2 different dimensions. And that's the difference in between 9 and the 10 and 11, kind of paired. And they kind of set that up so that you could exist in between 2. Now, what I was saying is saddles are very, very realistic. And what I was saying about there being 11 dimensions, what would an 11-dimensional saddle look like? We're going to try and find on the web if I can find you a picture of an 11-dimensional saddle, which is very, very weird. I have something new to propose. Think about it this way. There is the space in which matter takes place, and the matter that occupies the space. And the time also occupies the space. This space occupies time, but that's something that we as human creatures are not necessarily that capable of thinking about. So you have space. And when I said each universe takes up space, each universe, like I said, infinite space. So think about there just being an infinite amount of space and you being in the center of it, since technically the only way you can observe infinity is in the center of it. If you try and go outside the edge, well, that's technically impossible since it's infinity. But let's just say that's that. If you go to another universe, you're staying in the same time and in the same place, but different things happen with time and different things happen with place. So maybe in one universe, you slip and trip and fall and bust your knee. In the other universe, somebody comes up to you and says, hey, and then you get distracted by them and strip and trip and fall and bust your knee. So that would happen about 1 or 2 seconds later. So the universes are practically the same until about one slip that you have. Now, here's the funny thing. How new universes are created is, think about it, every universe is just one tiny bit different. I like to think of it like, well, there was some guy, and I never really remember his name, but he came up with the concept of being, of having multiple levels of infinity. I like to think of it as, originally there was one universe, and it was, well, think about it going down this way. If you go down, you're going to have atoms, right? And then you're going to have particles, and, or like protons and, hadrons, and then you're going to have beta particles, gamma particles, and then you go down further, you get quarks and neutrinos. But if you go down further, you could almost think about matter as not being made by particles, but being made up by itself. I mean, these are infinitely small particles, and don't just think of somebody just made out of particles. Think of somebody made out of what they're made out of, which is not particles, but it's matter. If you think about this, maybe one, the smallest form, it will form its first matter. The first differentiation you can have before space is time. So maybe it starts, maybe it forms its first of matter in 1 second, and the other starts its thing of matter in 2 seconds. Well, originally, like I said, you start off with one universe. So you have one basic universe. And let's just say, maybe magically coincidentally, since this is really the only way we can think about it now, you have space, and it forms the first quarks. And everything's going the same, although then, if you look at one universe, that universe the beginning of it, it was the same as all the other ones, but it formed a different quark. So let's say the first one, like all the universe was the same, although then if you look back in time, one universe formed an up quark and one universe formed a down quark. Although originally they were the same universe. So what causes them to split like this? What causes them to change? Well, you could probably say that it's the rate at which matter turns into energy, and it's light. If there was a lightless universe, you could see nothing, then, that would be technically impossible. Now, sorry if there was a strange noise, there was just some ding thing that went off on my computer. But, let's say you did have a lightless universe. What would probably happen was there would be no transaction, so there would be one universe. But think about this. There's so many changes that could occur in the universe, but since we believe that the universe is infinite, there's an infinite possibility of changes that could have happened, and thus infinite universes. Now, this is just a little mind exercise I like to have, and also, as well as having an infinite amount of space, it has an infinite amount of space now, but it also did maybe like 12 billion years ago, and of course it's 13.8 billion years ago I'm referencing. But let's say maybe it was 12 billion years ago, it still had an infinite amount of space, and so then there would have been an infinite amount of changes then. But the possibility that change happens is, changes can't just happen like every second. Changes happen and this is the same thing. You could say that time is made out of particles. Seconds, minutes, hours, days. But if you boil it down, time is basically just a continuous, kind of path that goes, and if you try and break it down into particles, well, great, you have time segments. But you can break those down to particles and keep breaking down and down and down, and you're going to get left with a very, very small amount of time. Now, this is what you call Planck length. But that's something else. And what we're talking about here is time that's infinitely small. Time that's, if you look at sand, it would be like maybe if you have kind of an avalanche almost, like a collection of boulders, you're like, how many boulders are in this? And I'm like, oh, that's easy because it's already broken down. Maybe let's say you make it smaller, you make it pebbles, and you make it sand. How many grains of sand? It's going to be immensely fine, but they're still particles. And let's say the sand starts to form a boulder. But sand doesn't really form boulders that quickly, and a bunch of other things happen, so it's just a boulder. You could say how many grains of sand are in the boulder. There aren't any grains of sand in the boulder, it's just a boulder, which means it's made out of nothing except for boulder. So that's the way I like to think about it. The point I'm getting to here is, as I was saying earlier, you have an infinite space in the... So the first rule actually leads to the second rule. If you have an infinite amount of space, and with the rule that change is possible, well, you have an infinite amount of times that the universe can change and split. And you have an infinite amount of space that the universe can change and split. So it's basically infinity to the power of infinity, which is also known as, you could basically just say Aleph infinity, or Aleph 1. So there's this guy who came up with this theory, like I was saying before. The countable infinity is Aleph 0. 1, 2, 3, 4, 5, 6, 7, 8. And you keep going on like that. But the next infinity is one infinity, and then a second infinity, and then a third infinity, and then a fourth infinity. But of course, each of these infinities are built out of ones. The second Aleph, or actually the third Aleph, Aleph 2, would be there is one infinity of infinities, and then there's a second infinity of infinities, and then there's a third infinity of infinities, and a fourth infinity of infinities. Well, I mean, of course there's Aleph infinity, which people say is the highest level of infinity, but this is Aleph 1 that we are beginning to approach. So, there you have it. There is an Aleph 1 number of universes. And, I mean, here's the thing. If you boil down, and even, here's the interesting part of it. Even if the universe is limited, then there's a limited number of particles, but still, like I said, you can boil that down to the fine grain until it's so fine that it isn't even grain anymore, and it's just one. If you boil it down that far, then you basically have an infinite. So if the universe was a cubicle inch big, then you would end up with infinite size of those particles. Although if it was infinite, then you would end up with infinity squared, which would be Aleph 1. But since it is infinite, according to Rule 1, you end up with infinity times infinity squared, which is Aleph 1. But then think about the number of universes, the time. Well, people say that, of course, there's going to be a Big Bang and a big crush, but according to this other theory that I have, if you have an infinite amount of space, it should represent an infinite amount of time as well. But the Big Bang did happen. I mean, there's some who say that the universe has existed for forever. It's gone on for longer than any limited number can count. Well, even that way, then you have Aleph 1. So you basically have Aleph 1 times Aleph 1. You get, actually, since that's 2, you would get Aleph 3, not Aleph 2. Since Aleph 0 is something it gets a little confusing there. Aleph 0 would technically be Aleph 1, and Aleph 1 would be Aleph 2. But if you have Aleph 2, then times Aleph 2 becomes Aleph 4. But since it's shifted down one number, it becomes Aleph 3. So, yeah, that's an Aleph 3 number of chances. Since the universe, since it's unlimited, is filled with, well, let's say any universe is filled with an infinite number of particles, and even like these small particles, if it's limited or unlimited, and if it's unlimited, then it's filled with an Aleph 1 number. And if you look at all the other universes, if there's an infinite amount of time that you can have, even if you break it down into 1 second, there's an infinite amount of times that you could choose on that. So let's say I'm going to start, let's say I'm just going to start an imaginary timer now. So that started. Now I'm going to pick a point in between when this timer starts and when it ends, which is right now, and I'm going to hit the table again. Now the timer's finished, since I've hit it again. But that could have been technically any other time. So if there's one universe, then there's an infinite number of times. And here's the funny thing. Since there's an infinite number of times, but a limited time that the universe is around, but an infinite number, well, an infinite amount of space, but an unlimited space, well, that would actually be Aleph 1, or for the sake of this, Aleph 2 times Aleph 1, which would actually become Aleph 3. And that would go back to Aleph 2. So, yeah, that's that. You have Aleph 2 universes. Now, it'd be nice if I could work this out for you and show you a picture, but yeah, that's what I have for now.